Okay, we've got a couple of different types of slope that we are going to talk about. Which one of these examples is the positive slope? D. I write that underneath it. Okay, we read slope going from left to right like you read a book. And when we go from left to right, this one's going up. I probably could have just drawn that on here, right? Which one's the negative one?
C.
It is. This is the negative slope. Okay, so when we read it from left to right like we're reading a book, it is decreasing. The function is decreasing, so that's a negative slope. Like if that was your bank account, you'd be real worried. All right, which one of these has a zero slope?
A.
A, good. So for this one, m equals 0.
M.
M is the letter that we use for slope.
Gotcha.
Yep. Okay, what kind of line is this if it just is flat? Starts with, yes, it's horizontal. Okay, have you ever seen, we'll talk about it later. Okay, what about the undefined slope? It's B. Big surprise. Undefined. Okay, have any of you ever tried to divide a number by 0 on your calculator?
Yes.
Yep, what do you get? You get an error message because it's undefined. Okay, so this is a vertical line. Okay, anytime you divide by a 0, a number by a 0, for slope, you get an undefined slope. All right, so now we get to talk about steepness. Steepness is a little bit different than which one is the greatest. If I ask you which one is the greatest, you have to account for the signs and you have to give me the most positive, okay? The most positive one would be this positive slope over here, right? But if I'm asking you about the steepness, we get to ignore the signs because we don't care if it's going up or going down. A hill is steep whether you're going up it or down it, right? So when we are looking for, you're correct, it is C. When we're looking for the most steep, okay, we're talking about something called absolute value and we ignore the signs. Okay, there's another name for slope. It starts with an R. It's actually 3 words. Rate?
Change.
Good, rate of change. Okay, we're going to use those interchangeably. We've also talked about how slope is M, right? Okay, so we can find slope a couple of different ways. We're going to do 4 big ones in this unit. Anything else we do with slope is really like a variation on one of these 4, okay? We can get it from a graph. Have you guys done this before with finding pretty points? Mm-hmm. So you have to look for where your line, your function, is crossing the intersecting grid lines. So it's like, when does the line get caught in the crosshairs? So here it's intersecting with the intersecting grid lines. Here, yep, that's another one. Okay, is this point here a pretty point?
Yeah. No.
No, do you see how it's in the middle of a box?
Yeah.
Not a pretty point. Not that one. All right, what about this one? No, it's only hitting one of the grid lines, not both. So I don't mean that one either. Does everybody understand what I mean by pretty point now? Okay, perfect. Okay, so then we make a slope triangle. This is a right triangle that we make. Okay, and it helps us find the rise over the run. Rise over run. The rise is our change in the y coordinates, and the run is the change in the x coordinates. You can remember this because rise and y's rhyme. That's nice. And it's a good idea to run from your x's. Right? Sometimes we just can't run fast enough. So, what is my change in my y's going from 3 down to 1? Yeah, it's -2. Okay, now what is the change in my x's going from 0 all the way to 3? +3. Okay? Which one of those do I put on top in my numerator? The -2. So it goes -2 over 3. Okay, did any of you write it like this? With the negative out in front? Those two are the same. These are equal. I could have also written it like 2 over -3, right? Those three are all the same. As long as there's only one negative sign, it's a -2/3. If I have two negative signs, they cancel each other out. Now I've got +2/3, right? Okay, you don't look convinced. I will work on that later. All right, we can also get our slope from a table. So we just came from Unit 3 where we did a lot with a table. And unless we were finding out whether an input had two outputs, we didn't really pay much attention to the x's, right? Now that we are getting more acquainted with the linear family, we're going to have to pay attention to the x's also. So look at this jump. From -1 to 0, what's my jump? Add 1. And then from -1 to 1, add 2. So which of those is the rise? Is the 2. So 2 over the 1, which reduces to 2. All right, look at this. What if I want, can we not do that? Thanks. What if we went from -1 all the way up to 2? What's that jump? Okay. What about from -1 all the way up to +5? +6. Which one of those is the rise? The 6. So if I put the 6 over 3, what does that reduce to? Interesting. Do you think it matters which pair of points I pick? Because linear functions are special. They have a constant rate of change. So I can pick any pair of points I want and find the jumps, right? And put the rise over the run, and I should get the same thing. What?
They're the youngest child.
Yeah. Okay, questions about that? All right, here we go. This is my favorite way, this next way, because this is the we just get to eyeball it way, and we don't have to do a whole lot of work way. We can tell what the m is from an equation. Have you seen this form before?
Mm-hmm. It's slope intercept.
Yeah, slope intercept. What? Yep. Slope intercept form. I kind of ran out of room. That's a form. Okay. So named because it has the slope in it and a y-intercept in it. So which is the slope, the m or the b?
The M.
The m. That makes sense, right?
Yeah.
This is the slope. Okay, the b value is the y from the y-intercept. Yes. So the y-intercept is 0, b, right? This is the y-intercept. So notice that the slope is the coefficient of x. Is coefficient. So what number is the slope, the 1/2 or the 3?
1/2.
The 1/2. Okay, what if I rewrite my little equation and I say y equals 3 plus 1/2 x? Now what is the slope?
1/2.
It's still 1/2 because the 1/2 is still with the x. Okay, so it doesn't matter what order those terms are written in. Okay, the slope is the slope because it's the coefficient of the x. Remember, we put the x with the expression that says per each or every. Okay, the per each or every is what tells us that it's a rate, right? The slope is the rate of change. The slope goes with the x. Cool? Okay, perfect. What about from 2 points? All right, this should look a little familiar. Do you have your pink sheets out? Not yet. Would you get those out?
Yeah. I got
Who needs one? Whoa. Would you pass these back? Anybody else back there need one? Okay, please keep these. All right, in the middle of your formula sheet, what do you see? Yeah, the slope. It's the slope formula. It's the same one I have up here on the board. Okay, so this will be something that you can use. Okay, but you have to know how to use it. So let's talk about how to do that. So, those subscripts, some kids get a little confused by subscripts. The subscripts aren't there to confuse you. They're there to help you figure out which x and y we're talking about. The subscripts tell you which point the x and y come from. So let's start by numbering our points. Let's call 6, -1, point 1. We'll call 5, 2, point 2. Okay, each of those points has an x and y. Would you label them now? Write a little x under the 6 and a little y under the -1. And same thing for the 5 and 2. Give them an x and y. Now, I've got 2 different x's that I'm calling x. How confusing is that?
Not confusing.
Well, so like if I just had a formula that was like this, m equals y minus y over x minus x, would we know which one to put where? No. So to eliminate that confusion, they just say, okay, well, if it comes from point 1, give it a little 1 for a subscript. And now we know which one goes where, right? If it comes from point 2, give it a little 2 for a subscript. Now we know which x and which y to put in which spot. It's kind of cool. So we're going to follow those directions and say m equals. Okay, get your fraction bar ready. Do you see that the slope formula has 2 negative signs in it? I suggest writing those in and then plugging in your numbers, your values. Let's plug them in. What is my y sub 2?
Y sub 2 is 2.
It is 2. All right, what about y sub 1?
1.
Okay, so what if I have a -1? What happens if I do minus a negative?
It becomes positive.
It turns to positive. That's why it's really helpful to have that negative already in there, because sometimes we'll forget it if it's not written in there first. Just saying. This is from my own personal experience of making sign errors, which is very vast. All right, what about x sub 2? What's x sub 2?
X sub 2 is 5.
It is 5, and x sub 1 is 6. All right, so to find my m, I have to do 2 plus 1, which is 3, and 5 minus 6, which is
-1.
-1. So how can I simplify 3 over -1?
Flip it.
Maybe just ask your calculator what 3 divided by -1 is.
-3.
Yeah, it's just -3. Okay, so for this next part, would you remind yourself that we can write a 1 under any integer without changing its value? So I'm allowed to write this -3 as a -3 over 1 because I'm about to ask you about which one is the steepest. Before, we had a picture. We had pictures and we could see which one had the bigger change in y and was steeper and which one had a smaller change in y and it was more flat. Okay? But for these, we don't have a picture of all of them. What we're looking for is which one, can we stop doing that? Which one has the bigger number, ignoring signs, ignore the signs, okay, the bigger number on the top and a little tiny baby number on the bottom. Which one has the biggest number on top compared to the numerator? Can you show me? I made a mistake. I did an A, B, C, D. Can we do 1, 2, 3, and 4? And then you can show me with your fingers. Okay, I have some votes for 2, some votes for 4, another vote for 4. Okay, so it's between these two. This one is the greatest because it's the most positive, but this one is the steepest because it has the biggest number on top, ignoring the signs. Does that make sense?
Yeah.
Okay, so we should pick D. It is the most steep. Any questions about why? Okay.
No.
Okay. Guys, we're doing good. We're doing good. Okay, now we have to use the graph to answer some questions. Here I've got account balance and months. What is happening to this account balance? They said you did a good job singing today. You did so well. My little songbird. So, sorry, what's happening to the account balance?
It is decreasing.
Decreasing, yes. Okay. So where is the Y-intercept?
The Y-intercept is 250.
Okay, that is the B value, and it is part of the Y-intercept. The whole thing is 0 to 50. What? Okay. What does the 0 represent in this scenario? The months. Okay. What about the 250?
The amount of money.
Yeah, that's the account balance in dollars. So I suggest, hey, can you put that phone away? I suggest labeling your Y-intercept with the units because after that, it becomes really easy to explain it. What? Can you wait? Okay. So now that we've got it labeled, the explanation is easy. At 0 months, what is the account balance?
$250.
Explained. That's it. That's what we write. So at 0 months, the account balance is $250. I just said what was in my point. Okay, now this is important. I can't just say how much money they started with. How much money they started with isn't really wrong, but it is not nearly enough information. Okay? I cannot give you any points for how much money they started with. I need at 0 months, the account balance is $250. Does that make sense? We need to be very specific. Okay. Next. We have to find the rate of change. Rate of change is talking about what? The slope. So I need M. So I need my pretty points. I got 250, 0, 250, and then which one do you want to pick?
2.
2 what?
200.
Okay. Make a slope triangle. What is my rise? 50, is it going up or down? So down 50, and then from 0 to 2 is going 2 to the right. Okay. And then can we reduce that?
Yeah.
Okay, negative 20. I put that in the weirdest spot. M equals negative 25. Okay, so I want to talk about a common mistake. A lot of kids will do this. -1/2 because they're just counting the boxes. Does everybody see why I can't say that negative 50 is -1? Right? Because it's going from 250 to 200, not to 249. Good? Okay. So not this. Okay, so now we have to explain the slope in the situation. Let's retrace our steps a little bit. Our negative 25 came from the negative 50, which came from the money, right? So the negative 25 has to do with the money in the account. The one that we are allowed to write under the negative 25 came from the 2, which was the number of months that it took to decrease $50. So the 1 is the months. So every 1 month, what happens? Yeah. So we need a lot of good words that mean negative, like leaving, loses, decreases, goes down, right? All of those words can tell me that something is negative, right? So we can just say something like,
Takes away.
yeah, takes away. The account balance, yep. Yep. I'm going to say decreases for the video, but you can say goes down. That's perfect. The account balance decreases by $25. How often? Yeah. Yeah. Every 1 month. So again, you can't just tell me how much it goes down by. How much it goes down by isn't wrong. It just doesn't tell me how much it's decreasing or how often. Or it doesn't tell me what is decreasing. It's missing all of the information I need. It's not wrong, it's just not informative. So I can't give you any points for it. Does that make sense?
Yes.
Okay. Cool. What? Yes, you can now. Thank you for waiting. Okay, so real quick, we're going to find these 3 problems are like the ones that we did on the front. We're going to find the rate of change real quick, and then we're going to compare which one is the steepest. So start by labeling your points 1 and 2. Then label them X and Y, X and Y, and give them little subscripts, depending on which point they come from. Then I want you to use your pink sheet and plug them into the slope formula. Don't forget to put the negatives in there before you start. And go. All right, so this is what I saw. Y sub 2 is 1. Y sub 1 is 3. X sub 2 is 0. And X sub 1 is negative 3. What happens if I do minus a negative? negative turns positive.
I'm sorry.
Okay, so that gives me 1 minus 3, that's minus 2. And 0 plus 3 is 3. So my slope is negative 2/3. Okay, let's do the middle one. Okay, so first we're going to find a change in x. So from -4 to -2, what's our jump? Plus 2. And from -3 to +1? Plus 4. Which one do we write on top? The 4. So 4 over 2 equals 2. Let's make sure that we did it right. We can check it with another point. So let's check an alternate point. Let's go from -2 to +1. What's that one?
Plus 4.
-2 to +, I'm getting plus 3. What about 1 to 7? Okay, plus 6. If I do 6 over 3, what do I get? 2. Good. Any pair I use, it would have reduced to 2. Yep.
Oh, when you finish, there's a bottom.
Yep. Okay. Here we want 2 pretty points. So up 2, right 2. This one is the rise. This one is the run.
It would be 2 over 2 equals 1.
2 over 2 is in fact 1. Okay, write in your ones under the numerators that don't appear to have denominators. And which one is the steepest? Don't say it out loud yet. Let everyone think about it. Okay, 15 seconds. I'm watching the clock. Which one has the bigger change in the y's, ignoring the signs? Okay, everyone say it together.
2.
Yes. I forgot what the answer was, but yes, you are correct. This is the steepest because this one is like 2 over 1 and this one's 1 over 1. These two are the same. This one, the bottom's bigger, right? On this one's the top is bigger. Cool? Okay. Last but not least, the final countdown. We have altitude versus hours of hiking. As time goes by and we're hiking, what happens to the altitude?
Keeps inclining.
Keeps inclining, keeps going up. So we have to identify and explain the rate of change in this problem. So what do we want? Slope or y-intercept? Slope. Okay, so we need some pretty points. Do you want to use this end point or like a different point?
60. Well, there's 2 and 60.
2 and 60, okay. So what is my change, my rise going from 30 to 60? Okay. And then my run is going from 0 to what? 2. So increasing by 2. Reduce it. 15. Okay, we also have to explain it. So let's label it as 15 over 1. The 15 has to do with what? Hey. Thank you. Okay, so 15, what does that have to do with? Feet or hours? It's the feet. Okay, if it's 30 feet every 2 hours, it's 15 feet every 1 hour, right? Okay, so the 1 is the hours. So when we're describing this, hey, how much does our altitude go up every hour?
15.
Yeah, so that's what we say. Altitude increases by 15 feet. Don't put it away yet. I need to add something. Every 1 hour. Okay, this is a perfect time to talk about domain and range. So I need everybody to go back to this problem because we left some space at the bottom. So what is domain? X's or Y values? Yes, the X's. So I'm going to highlight for this function, which starts and stops, right? It doesn't go on forever. Okay, I'm going to highlight where my X can be. What is the smallest possible X value that we can have for our hours of hiking? 0. Can we have negative hours of hiking?
No,
No, it doesn't. Will you turn that off? Thank you. Okay, so the domain is 0 to 6 hours of hiking. Okay, hold on. Hold on. What about the Y values? What is the lowest possible Y value? No. 30. Do you guys see that the altitude goes from 30 to 120? Okay. So the Y values go from 30 to 120. So altitude goes from 0 to, no, not 0, 30 to 120.